Today we're going to be looking at 13.1.9, the first section of chapter 13, problem 9. And we're going to look at the iterated integral, the first from 1 to 4, the inner from 0 to 4, and of square root of uv du dv. Okay? So how are we going to approach this problem? It's going to be just a step above what we did last time. So now we are going to say, okay, well, we need to evaluate the inner integral. So sometimes it helps me to just write a little thing here. And so we're going to evaluate the square root of uv. So what is the integral of the square root of uv? Okay, well, if you think about it, this is uv, square root of uv is uv. So we could say this is uv to the 1/2 power. Now, it's good to write your square roots in terms of powers because it's easier to think, for me at least, of how you need to integrate them in terms of the boost and divide method that we're used to. So here we're going to hold v constant because it's outside, it's just along for the ride, and we're just going to integrate with respect to u. So v stays exactly as it is, but we integrate u. So what is the integral of the square root of u? The antiderivative, du, is equal to the integral of u to the 1/2, which is equal to u to the 3/2. So 1/2 plus 2 over 2 is 3 over 2 over 3 over 2. And when we divide, when we have two divisions, the bottommost comes up to the top. So if we have a over b over c, you probably know this, but basically I think of it as flipping this up top and this comes to the bottom. So we have a over b times d over c. Okay, you just flip it upside down and multiply it by the numerator. So in this case, we're going to get 2/3 when we flip it and multiply it by the numerator. And at the same time, we can just bring it out of the integrand. So what we get is 2/3 u to the 3/2 v to the 1/2. Okay? And this is evaluated from 0, we'll say u equals 0 to u equals 4. And we have dv out here. So far, so good. Now, what is the next step? Well, first we need to evaluate this inner integral. So we plug in 4 here, and one thing that is good to note is that 4 to the 3/2. Well, what is that? Well, the best thing to do is think of 4, we want 4 to the 3/2. So the best thing to do is think of 4 to the 1/2. And we all know that that's equal to the square root of 4, which is equal to 2. And then we can tag on that to the 3rd power. Okay, so we can you can multiply exponents just like you do regular numbers. So that's 3 times 1/2. You can think of that in the exponent. So we can deal with them separately. So we all know that 2 to the 3rd is 8. We should. 2 times 2 times 2 is 8. So we get 8 when we plug in for the top limit. So we get integral 1 to 4 of 8. Let's see, we'll pull the 2/3 out because it's just a constant, and we'll evaluate u. So we decided that this is 8. And then 0, plugging 0 in for u is just going to give us 0. So 8 minus 0 times v to the 1/2 dv. Okay? So this is 16/3, and we can pull that out of the integrand, and we get 16/3 integral from 1 to 4 of, you guessed it, square root of v dv. Now, of course, this is v to the 1/2, so we'll look at this integral. This is equal to 16/3, and we're going to boost and divide. We say v to the 3/2. We just did this, so shouldn't be too big a deal. So 2 v to the 3 halves over 3. Okay? And then that's from the limits of 1 to 4. So I'm doing it different ways to show you how you might go about writing it once you get maybe a little more comfortable. But up until then, you might want to write v equals 1 to v equals 4. And this is equal to plugging 4 in here. Again, this is going to be 4 to the 1 half is 2, to the third is 8. So this is 16 thirds. So we get 16 thirds times 16 thirds minus, then plugging 1 in here. 1 to the 1 half is 1, to the third is 1. So we get 1 times 2 is 2 over 3. So minus 2 thirds. And this is going to be 14 thirds. So our answer turns out to be 16 thirds times 14 thirds. This is going to be equal to 224 over 9. So the 3 times 3 multiplies, and the numerator becomes 224 over 9. For extra practice, you might want to flip it around, the variables of integration and the integrals, and see if you should get the same result. So thank you for watching. Hello everyone. We're going to look at one more problem of an iterated integral. This one's going to be involving an exponential. E to the x plus y is our main function. You could think of it as your z function. So how are we going to do that? First, we're going to look at this inner integral, as we have done several times before. So we're just going to bring this 1 natural log of 5 along for the ride, and we're going to evaluate e to the x plus y. And what we're doing is we're integrating with respect to x and holding y constant. Okay? So e to the x, what is the integral of e to the x? Well, it's just e to the x. Same as its derivative. It's just e to the x. So we have e to the x. We could say e to the x times e to the y, because remember, this is equivalent to e to the x plus y. You can separate them. When you add exponents, you are multiplying by the base to the exponents. So we have e to the x times e to the y, and you can separate them just to help you think of it. And then we're going to evaluate this from 0 to natural log of 3. So plug in, never forget to bring your dy along for the ride. So now, natural log of 3, plugging into x. We need to evaluate this, 1 to natural log of 5. And so, what are we going to get? All right, so we have, when we evaluate this, we have e to the natural log of 3. When you have e to the natural log of something, the e to the natural log cancels out, and the 3 is brought down to earth, you might say. So we have 3. Actually, since this e to the y is held constant, we can bring it outside and just evaluate the limits for e to the x. So we have 3 minus, now plugging 0 into x, e to the 0, that's equal to 3. E to the 0 is equal to 1. Actually, anything to the 0th power is 1. So we have 3 minus 1 dy, all right, which is 2 e to the y. We can pull the 2 out of the integrand. So we have 2 is the integral from 1 to natural log of 5 of e to the y dy. And as before, the integral of e to the y is just e to the y. So we have 2. We can evaluate it. So we have e to the y evaluated from y equals 1 to y equals ln 5. I've gotten in the habit of pronouncing it ln. I don't know how that started. A lot of people say ln. I say ln. I think some people in Europe might say it that way. But anyways, I've always thought that saying natural log all the time is a little bit, I don't know. It's a time taker. I mean, it's a little bit annoying. So come up with your own phrase. ln is a pretty popular one in America. So now, evaluating it, we have 2 times, now remember as before, e to the natural log of 5, e to the natural log cancels, so we just get 5. And we have minus e to the 1, so e to the 1 is just e. So our final answer equals 10 minus 2e.